Thank you so much, Hannah, and thank you everybody for being here this morning. My name is Nash. I am a developer relations engineer at IBM. I work mostly on the Langflow project. Langflow is an open source drag and drop builder for building agent applications, building applications with AI. And if you do want to find out more about that, I'm upstairs with a little desk. Come and chat to me there about it. Of course, if you want to find me anywhere on the internet, I'm pretty much Phil Nash everywhere. I'm mostly happy with the fact that I got Phil Nash as a domain, and just been delighted about that since I got it. Every time the island of St. Helena charges me more for it. But what I want to do today is talk about agents. And I know there was a session yesterday which went into agents and how you understand them, because 2025 really has been the year of agents coming around and building with them. And according to our survey results, not necessarily using them, but at least maybe building them and learning about what they are. And what I wanted to do for this session was really kind of strip back and understand how that works by building one in front of you. Because how agents work under the hood, when we understand how that works, we can be more confident about what we're doing with them and how we can go ahead and build them as well. And so it's probably best to start with some definitions of it, so we're all kind of at a base level. And so in a paper published in September of last year, a number of people at Google wrote that a generative AI agent can be defined as an application that attempts to achieve a goal by observing the world and acting upon it using the tools it has at its disposal. Then at the start of this year, Jensen Huang of NVIDIA said that agents are AIs that can perceive, reason, plan, and act. And those things kind of match up quite nicely, right? An AI that can perceive is observing the world. Reasoning and planning is about kind of trying to achieve a goal, and acting using the tools at its disposal. But more recently, Simon Willison, who writes about these AI things an awful lot of the time, has come up with, or settled on, a definition that is a little bit more straightforward and is what we're going to see today, that an LLM agent runs tools in a loop to achieve a goal. I like that because it's simpler, and it actually is very much the mechanism of what we're actually going to build. It runs tools in a loop until it gets to that goal, or until it can't get to that goal. We're not running in a loop forever. We have a goal to achieve, and we're going to try and run tools until we get there. So let's build something. I'm actually not going to do a lot of slides for this. We're going to go and build an application and see it. The application right now is terrible. It's not very useful. You can see it at the bottom of the screen there. And if I say hello, it echoes it back to me. It's the worst chatbot I've ever built in my life. And most of the code that already exists doesn't really matter, but what we have is our agent object, and that agent gets asked at one point to respond to some user input. That's all, and it's going to make a response. And our existing response right now is that it echoes back what we said. Terrible. So let's do something about that. We're first going to have it generate some content. That's nice and easy. And I've got a couple of little helpers here. This GenAI helper here is actually just the Google SDK for talking to the Gemini API. So we're using Gemini for this, but actually the model that we use for this doesn't really matter. They all work basically the same for this. We also have some options which I'm going to be adding to it. So the model is, in fact, Gemini 2.5 Flash, and it's told it's a helpful assistant. Good stuff. So using that, instead of just echoing back the results, we're going to, we're going to give it some options, and we're going to merge those options. So it's just a little bit of tidying up there. And once we've done that, instead of returning this echo, what we're going to do is create ourselves a response from that API. So the response is waiting for the GenAI the GenAI SDK to generate some content using the prompt that we put in and the options that we defined. And instead of echoing back the result, we are going to return the response text. Lovely. And so now we have something that can generate some content. So if I say hello to it, it will say hello back. Hooray. And now we can test that it's generating interesting content by saying, tell me a joke about AI developers. What we'll find out from this is that models are terrible at humor, but it is actually going to generate some stuff. It's thinking about it, which is good, but we'll get there in the end. what we'll find out with this is that we are just generating content new each time. There is no, there we go, ooh, ha. Why did the AI developer break up with their partner? Because they said, I just couldn't get enough labeled data for our relationship to generalize effectively. Cool. Nobody said they knew how to write jokes. But what they also don't know is how to remember things. So if I tell it that my name is Phil, it's happy to know that, but if I ask it what is my name, it has no idea. Oops, let's try that once more. What's my name? As an AI, I don't have access to personal information about you. Yeah, cool. So it doesn't know. So we need to give it some memory. Memory wasn't really defined as part of any of those definitions of our agents, but it is important, because if the model doesn't know where it is in the conversation, it can't achieve that goal that we started with. And so, thankfully, the Google Generative AI SDK makes it nice and easy for us. We can actually just create a chat and give that the options, and then use that chat to generate stuff. And all it's doing underneath the hood is storing all of the messages that we send to the model, and all the messages, all the responses it gets back, and sending them all each time. That's the simple version of memory, and it just works. So if I do that, we've changed to using chats instead of the regular thing. I can now say, my name is Phil, and it says, hi Phil, nice to meet you, and then I can test its knowledge. There's my name, your name is Phil. So we have memory, cool. But we're still not building an agent yet. We've built a chatbot. We've built something that we can converse with. Fun. So what we need to do is run tools in a loop until we achieve a goal. That's what we define it as, and so we now need to create that loop. I like to test these things with, I give it a simple question that it can't answer, like, what is the date today? What do you think it's going to say? It's been answering me June recently. Oh, May 14th, 2024. Incorrect. Wrong. Try again. May 15th. Thanks for correcting me. You're absolutely right. It's a classic agent. We're going to build a loop. And what we're going to do is provide this agent with tools that it can choose to use if it wants to achieve that goal. And when we do that, instead of just responding with text, which we've seen here, we will find that if it wants to use tools, it will ask to do so. And so we're going to give it a big loop, say while this agent wants to use some tools, so while the response has function calls that it wants to call, and I'm just gonna, things didn't work unless I did this earlier. Length is greater than 0, so make sure there is at least one function call in there. Whilst we do that, we're going to call those functions and give the agent the responses back until it has worked out whether it has answered its question, achieved its goal. And so this is going to take a little bit of work, but we're going to get some function responses. And it can ask for more than one function call at any one time. It's smart like that. But we're going to wait. So there's a bit of JavaScript in here, which I'll try and get through quickly. Promise to all. We're going to go over all of the function calls that it wants to make and map over them. And for each of them, we'll call it using the functions that we gave it. So to do that, each of these function calls actually comes with a name, and the arguments, so we can get those, the name of the function and the arguments that it wants to call them with, and then we get that response by calling the function. So we will store some incoming functions in this dot functions from the options dot functions. So that's kind of storing the functions we want to call. And it's important that actually, like, the model here is not calling the functions, it's just asking us to do so. It's up to our code to find each function that it wants to call and then call it with the arguments. And once we've done that, we just return a function response that is made up of the name of the function and the response from the function that we called. And so that is our big loop. That is our, over all of the functions that the model would like to call, we call them and give it back the answer. And then right at the end, we just make ourselves a new response by calling off to the chat by sending it a new message, and this message doesn't include any text that we sent it, but the function responses that we just created. And that is all we need to do to build an agent. This entire thing is 35 lines of code, and that's it. Of course, it still works. Hello, you still there? Cool. But I haven't given it any tools to use yet. And so that's what we need to do next. We're going to come back over here. This is where we initialize our agent. We're going to give it some tools. Now, I wanted it to know what the date was. And so I've already written that, so we have to stop writing too much more code at this point. And I have two things for this tool. I have a declaration, actually telling the model what the tool is and how to use it, and then the actual code. And so the only thing we send to the model is this name and description. We say, hey, this is what the function is called. It's called date. And the description is, it gets the current date and time. Don't guess it. These descriptions are important because they allow the model to choose to use the tools. The description is the most important thing, and if this took parameters as well, you would have to describe each of those parameters so that it would know what to do. And so if we can now provide this to our agent by giving it a tool declaration of the date function declaration. Where have you gone? And we'll also pass it the function to call, functions, which is this date function. And now, if I ask it, what is the date today? We should see it thinks to get the current date, and it now knows it's October 16, 2025. Hooray, it's a smart agent. I, of course, am quite lazy, so I don't want to spend a bunch of time building more tools in order to get my agent interested in this kind of stuff. And so instead, we're going to have a quick dive into MCP. MCP, I believe, was mentioned a bit yesterday, but I know I've spoken to some other people that hadn't heard about it before. And MCP is the Model Context Protocol. MCP it's a standardized protocol for agents to interact with services. It was the people at Anthropic came up with MCP in the first place in order to help provide tools to their Claude agent, but they standardized it so that we could use this in agents across the industry. MCP has kind of two parts to it. An MCP server makes available resources, which are sort of more static, like data resources for an agent, tools, much the same as we've been building and seeing so far, and prompts, which are suggestions of how an agent might talk to that MCP server. And then the client side of it interacts with those MCP servers on behalf of the agent. So existing clients are things like Claude or Cursor or Windsurf. ChatGPT does have it now, but it's in dangerous developer mode. And our agent that we've built today is also going to be able to do this. So I'm going to add an MCP client to our agent to provide it with some more tools and give it more functionality. I've also already written these bits, so I'm just going to uncomment a bunch of stuff, because 20 minutes is only 20 minutes. And what I have here is a file system client. And so what's happening here is it is starting up an application using Node.js called, this is an MCP server built by the people behind the Model Context Protocol, and it just gives me access to the file system. And we create our client inside of our project, connect it to the file system thing, and then there's a bunch of stuff which just turns what the what the server returns into something I can use in the JavaScript. But you don't need to care about that, because all we're going to do is bring in the tools and the tool declarations that the MCP server provided to us. And when we do that, we can also bring them into our agent, file system. So we get the tool declarations in there, we get the functions in there, and this should give the agent access to the directory in which it has its own files. So I can say, what can you see in the project? And so it's, can't see anything. Excellent. It did this to me earlier, and I'm not going to waste any time because I did something slightly wrong, and this should fix it. Let's try that one more time. What can you see? Oh, it's doing stuff. So it's reading a bunch of files now. It got the access back to it. It's reading all the files in the project. Look at that. Eventually, it's going to tell me about this project, which is kind of exciting. When I did this earlier,
Oh, yeah, right. So there's a lot of stuff it said about it, but in essence, this project is building an AI agent that can interact with users utilizing various tools and leverage Google's generative AI capabilities within a model context protocol framework. Yeah, pretty accurate. I'm sad, a little bit sad, because earlier in practice it told me it was a sophisticated agent. But it's obviously learnt since. But that's just being able to read stuff. Like, the actual real essence of agents is that they can do things, they can change stuff. And so I should be able to say, look at source agent.js. That's the thing we've been working in, building up, and come up with some improvements. And write them in source, refactored, agent.js. So I'm asking it to improve its own source code and write that out as a new file. And so it's thinking about that. It's going to do that. And once it does that, we can have a look, see what it changes. Normally it adds things like logging and error handling, because I didn't do any of that. Oh, look at that, there it is. So it's given me a bunch of other stuff. Whoa, I don't know what it's doing. Anyway, what we're going to see is, now you can say, okay, update source index.js to use that new agent. What we should see actually is it'll change index.js and then it will restart itself, because now it's using the agent that it wrote itself. And we should be able to see if it's there. Still works. Okay, tell me about the differences in source agent.js to source refactored agent. And this will tell me how it's much better than writing code than I am. Well, let's think about it. It might have also broken its own code because it wrote it and it might not work. We'll come back to that. It's definitely thrown itself into a loop. All right. No, look at that. I would need to see the actual code. All right, cool. So this is cool. Skynet didn't happen today. It didn't take over and rewrite itself much better. But the fact that it was capable of reading itself, writing itself, and building it out in what we proved was effectively this code here, 35 lines of JavaScript. That's all you need for an agent. And that makes it your turn. An agent, an LLM agent runs tools in a loop until it can achieve a goal. That loop doesn't have to be very long and very complicated. It's the tools that we build around it, the framework that we build on top of our agents that give them the agency and autonomy to make effect in the world. It doesn't take a lot of code. Obviously, there are many more frameworks which probably have a lot more involved in it to make it easier to use, a bit more logging and a bit more error handling as well, unlike my code. But that's the essence of the whole thing. And so now it's your turn. It's your turn to build on this and take it out into the world. There's a QR code if you mind throwing the... If you want to keep up with this, I am currently writing the newsletter for Langflow. We share news on what's going on in building agents and AI applications for developers. And I would love it if you signed up and take part in that. I genuinely write the entire thing myself. And so if you sign up, it'll be wonderful. And I also feel every single unsubscribe as a dagger to my heart. So thank you for that. That is all I have for you this morning. Other than that, again, my name's Nash. I'm a developer relations engineer at IBM on the Langflow project. If you want the code for this, it's behind this other QR code. And other than that, enjoy the rest of the conference, and thank you so much.